Hi guys, my name is Vasya Pavlov and among other things I have been a competitive programmer for the past 10 years or more. I love competing and recently, just a few days ago actually, last weekend, me and my team, three of us, participated in the biggest programming contest in the world called IEEEXtreme, which lasts for 24 hours. There were 30 tasks. We managed to solve many of them, but not all of them. And my goal with this video is to solve all, basically it will be a video series. So my goal is to solve all of the problems myself and also share this knowledge with everyone who's interested. And this way I will also be like starting my new YouTube channel, obviously which has been my desire for a very long time, but I've never had the motivation or the courage to do it, to start it. So now is as good as time as any. So let's begin. Basically, my main programming language is C++, so I will be coding in that. And I will be starting the problems in the order that they were given during the contest. Let's begin. The first problem is let's cheer up Bob, which has a time limit of 1 second, memory limit 120 megabytes. The problem basically asks us to play a game of tic-tac-toe and to lose it on purpose. So we are playing versus Bob, who has his list of moves predefined. We are given that list as input, which is a maximum of 9 moves. And we should make sure to lose as soon as possible. So basically, there can be, of course, multiple ways to play the game. As it says here in the output, I think, fewest moves, you should choose the move. Yeah. So if there are many sequences that make you lose in the fewest number of moves, you should choose the one that is with the lowest numbered row. If there are still multiple, then the lowest numbered column. So what this says is that we should prioritize rows and then columns, which is nothing more than looping first over the rows and then over the columns in the for loops. Okay, so you can read the problem. I will post it in the description, and there will be a link also to this practice session for the contest. You can find all of the problems here. Okay, so let's begin. Let's talk about the idea, how to solve this problem. So Bob has predefined moves, and he always starts first. We can read that somewhere here. Will be a short. Okay. Here it is. You will insist that Bob makes the first move of the game. Okay. So Bob makes a move, you make a move. Bob makes a move, you make a move, and so on, until Bob wins. You must ensure that Bob wins. Okay. So what's the strategy here? Well, obviously Bob plays greedily, right? He uses a greedy strategy. Actually, it's not a greedy strategy, it's simply a predefined set of moves. So if he starts first, he will always do the first move, and then we will make a move, and if then he will try to execute his second move. If on that field of the, let's call this a matrix, 3 by 3, if we haven't placed an O in that field, he will place an X. And if we have, then he will simply jump to the next move. So that's it. The way to tackle this problem is, the easiest way basically, is to use breadth first search, simply because breadth first search will give us the shortest path whenever we search many states or searching a graph or whatever. If there are no if all the distances between a state and the neighboring states are with the same weight, then breadth first search will work. You can also use Dijkstra's algorithm here, but it's an overkill. There's no need. So breadth first search is the way to go. If we, for example, want to use depth first search, that will probably not work. It will not lead us to the. It will not lead us always to the shortest possible sequence of moves, right? Because depth first search goes in depth. It does not check the neighboring states first, all of the neighboring states, and we might miss the goal, which is a neighboring state, and we might go somewhere deeper in the field of states. Okay, so let's start coding. What do we need? Let's start with the input. Okay, so the input is always a sequence of two integers, like a sequence of 9 pairs of two integers. That is the row and the column where Bob will place his X when his turn comes, in that priority. Alright, so let's start coding. Bob row, we have 9 of these. Bob column, we have 9 of these. Alright. For the input, for almost all contests like this, I prefer to use to read from file instead of standard input, because it makes for faster testing. I do not have to copy the input in the console all the time over here. I simply place the input once here in a file and it's always read from there. Let's do that. Here we go. Alright, so sorry. In order to read from a file, we will use a stream, if stream. We don't need cin because we will only be reading from a file. So our file is called input.txt, and then okay, it says we have not included fstream. All right. Then we have a sequence of 9 pairs of integers. So let's loop over them and read them all. So we first read Bob row, and then Bob column. Okay. I have a problem here. What's the problem? Bob row. What is it saying? Oh, sorry. Bob. There we go. No problems. Okay. When we are working with states like this, I mean, one state is this, the current situation of the board, right, where we have X's and where we have O's, and we also need to keep track whose turn it is, right? Is it Bob's turn or is it our turn or my turn, whatever. We also need to keep track of which is the next move that Bob needs to execute by priority, right? He will start with the first, and then he may go to the second, but sometimes he will not be able to execute a move because we placed already an O on that field where he wants to place his X, and he will need to jump to the next. So we need to keep track of which move is his next move. All right, so let's define this state. I will use a struct here, a struct state. So we need to have the matrix here, right? It's a character matrix. I call it mat, short for matrix, 3 by 3. We also need to keep track whose turn it is, right? Boolean Bob's turn, right? If it's true, it's Bob's turn. If it's false, it's my turn. We also need to know the next number of the move that Bob will execute, right? So it will be something like int move number, and we need to keep one more thing, because the output asks us to print the sequence of moves that we execute. So for each state, we need to know which moves we have executed and in which order. So for that, I will use a vector pair my moves. Okay. I think that's all. We need, what do we need here? Maybe something like this. No, it's a mistake. My moves. Okay. Oh, we need a vector. Okay. That's done. So now that we have figured out what is a state and we have done the input, let's focus on, let's check, how do we check when someone has won? So basically we will continue with the breadth first search until Bob wins. When Bob wins, when we find a state where Bob wins, we are done. But in the meantime, it can happen that no one wins for some states, right? Initially, no one wins. There is not even a single X or O on their field. Also, it could happen that because we are trying a breadth first search, like it's like a brute force, so it can happen that we win by accident, and we don't want to continue playing that game. We just want to throw away that state. So we need to know from a single state if we have won, or if Bob has won, or if no one has won yet, so we can continue playing the game. So basically we will need a function to check who wins for some state, let's call it X. Alright, so let's return 0 if no one has won. Alright, let me write this here. -1 means we win. We win. 0 means nobody has won yet. And 1 means Bob wins. Okay. How do we check who wins? So, as you probably know, in the game of Tic-Tac-Toe, the winner is declared by having 3 of his symbols, whether it's X or O, in a row or in a column or in any of the diagonals, the primary or the secondary diagonal. So we need to check all of those. Alright, let's check for rows and columns first. I will iterate over all rows, which are 3. Iterate over all columns, which are also 3. Now, for each row, I need to count the number of X's and the number of O's. Okay, and count X equals 0, and count O's equals 0. Okay, so if X dot matrix of ij is equal to X, then we increment count X. And if X dot matrix of ij is equal to O, we increment count O. Now, after iterating, so this is for each row, and for each row we check each column, right? So for the first row we check all the elements there, for the second row, and so on and so on. Now we check here if count X is equal to 3. So if all of them are X's, we simply return Bob wins, which means 1. If count O is equal to 3, means we win, we return -1. Okay, so that was for the 3 rows. Now we need to do this for the columns and the diagonals. Okay, I will simply copy this code because it will be very similar. The only difference is that now we iterate first the columns and then the rows. Okay, so I can change, because I always use J for columns and I for rows. It's easier to remember and to manage. So I will just change this to J here, and I will change this to I. Okay. So what we did now is, first we check each column and we iterate over the whole column here. And we count X's and O's. The rest of the code remains the same. Okay, that's done. So I can write here, check all rows, check all columns. Now we need to check the diagonals. Okay, so each diagonal has only 3 elements, so this will be a bit easier, I mean shorter to code. Let's iterate over the 3 elements in the diagonal. So the primary diagonal will be this II, right? And the secondary diagonal will be element I and 2 minus I, right? Can you see it? So if I is here, if I is 0, then this will be 0. So 0, 0, 1, 1, 2, 2. And here it will be 0, then 2 minus 0, which is 2. So element 0, 2, 2, 1, 1, and 2, 0. This is what we get from this simple formula 2 minus I. All right. We need to check both diagonals. Okay, so int count primary diagonal, okay, equals 0. Int count secondary diagonal equals 0. Now, if x dot matrix of I is equal to x, count, oh sorry, we need to count x's and o's. All right, so count primary diagonal x equals 0, count secondary diagonal x equals 0, count count primary diagonal O equals 0, and count secondary diagonal O equals 0. All right. So if matrix of II equals x, this means that we need to increment count primary diagonal x. If, okay, we can delete this, x dot matrix of II is equal to O, count primary diagonal O, increment. If x dot matrix of I, 2 minus I, is equal to x, count secondary diagonal x, increment. If x dot matrix of I, 2 minus I, is equal to O, count secondary diagonal O, increment. Okay, so we just need to check here. Now, if count primary diagonal x is equal to 3, or count secondary diagonal x is equal to 3, then Bob wins. So we return 1. If count primary diagonal O is equal to 3, or count secondary diagonal O is equal to 3, then we win, return -1. So this is a bit long function, but all it does is very simple things. Check rows, check columns, and here we can write check primary and secondary diagonal. Okay, so if we find the solution, we return it. Otherwise, we return 0, which means the game can still be played. There is no winner yet. Let's go back to the main function and continue coding. What we need here is initial state, right? In order to start a breadth first search, you need some initial state and you need a queue. Okay, good idea. So we need to import a queue. There it is. Our queue will contain states. So let's define it here, queue, state, queue, called queue. Also, we need some initial state. Initial. There we go. Our initial state will start with, let's see, the matrix will be empty, so let's do that. Initial dot matrix dot, sorry, ij is equal to dot. Dot means empty. Okay, either dot or x or o. Now Also initial dot, what else we have, move number equals 0, because we are on the first move of Bob's moves, right? We haven't executed any moves, so his first move will be index 0. Okay, and then we need to check the turn. So yes, it is Bob's turn. Okay, we are ready to start the breadth first search. How do we do that? Well, we simply push the state to the queue. Okay, then we say while not queue.empty. We need some space here. All right. Okay, we need a new state here. Temporary state temporary equals queue.front, and we pop the state from the queue. Okay, now we need to check whose turn it is. Well, actually, we need to check if someone has won already. So if int winner equals who wins of temporary state. If we win, that means it's a bad state, so we throw it away. So if winner equals if we win was -1. So if we win equals -1, if winner equals -1, we simply continue. We don't want to go any further. If winner is equal to Bob, which was 1, we need to print the result. The result, as we said, was stored in this vector here, in my moves. So we iterate over that vector for I equals 0, I less than temporary dot my moves dot size plus plus cout temporary dot my moves of I dot first. It's a pair, so we have a first and a second element. Temporary dot my moves dot second. My moves of I dot second. New line. That's it. And then we simply break because we are done. We want to get out of this loop. Now I forgot one thing to do here. So since we are working with a matrix of 3 by 3 and starting indexes from 0, so with 0 based indexing, and the input is given with values from 1 to 3, we need to decrement them by 1 as we input them. So Bob row of I minus minus Bob column of I minus minus. Alright, and also when we print the values here, they are expecting them to be in the range from 1 to 3, so we simply print +1 for the row and column. Okay, so winner is 1, Bob has 1, we are done. Okay. Otherwise, we continue simply with the breadth first search. We do not have to put any other conditions here. Now we have two options for the current state. It can be Bob's turn or my turn. So let's check that. If temporary dot Bob's turn, right? If it's Bob's turn, Bob has to execute his next move. Okay, so his last move was temporary dot move number. Okay, so we iterate over all his remaining moves to find an available move to make. The last move. There are a maximum of 9 moves, indexed from 0 to 9. So we iterate over all of them, and we need to check whether we found a move. So we need to exit. If we execute one of his moves, right, they have a priority. So if we execute move 2, we do not want to execute move 3 immediately. So we want to skip it. So boolean done equals false. So when this, while this is also, or let's call it move found, while not move found. Okay, so when we find the move, it will exit this for loop. Move found. Okay. Now let's see. Let's call this R equals to, what was this called? Bob row. Okay, Bob simply for simplicity. Basically, we can do it without this, but it's better for it makes for cleaner code. Column, bob column, I. All right. Now we need to check if that field is available. If temporary state dot matrix of RC is equal to dot means it's available, that means that Bob will play that move. We do this temporary dot matrix of RC, we place an X simply on that field. We increment the number of moves, so basically temporary dot move number is equal to, no, we do not increment it, we set the next move. So he executed move I, the next move will be I plus 1. Okay, and it was Bob's turn, so now it's our turn, so Bob's turn equals false. I think that's it. Now we need to place this state in the queue. Push temporary, right? And okay, we need to set move found to true, and it will automatically exit this loop. That's it. So that's it if it's Bob's turn. Now else, this means it's our move. Now if it's our move, we want to try all the combinations, right? That's breadth first search, brute force, whatever. We need to simply check all of the combinations. So let's try all the possible 3x3 fields, 3x3, actually all 9 fields. Okay, so if it's not available, if temporary dot matrix of ij is not equal to dot, then continue. I always like to place brackets like this, just habit. Okay, so if we come here, right, and that means we have found an available spot which we want to try. So we create a new state, which will be equal to the old state, which was temporary. Sorry. Now what will change? Well, new state dot matrix of ij equals to. Now we place a no because it's our turn. Also, let's see the state. What the state here? Bob's turn, right? It was our turn, so now it will be Bob's turn. New state dot Bob's turn is equal to true. What else? Move number will not change since we are moving and not Bob. And we want to add our move to this list here, so we can print it later. So my new state dot my moves dot pushback make pair I j. All right. Well, I think that's it. Let's write. Did we copy the input? Yes. Okay. Run. Nothing happened. Well, let's debug. Okay. Barbara. Okay. So we have our elements from the input. They are read correctly. Okay. Initial. Do we enter here? Yes, we do. Right. Wins. Winner. Move. See what happens here. How many iterations we have? Only a few. Okay, so let's print our matrix. Okay. This is just for debugging purposes. Okay, so Bob executes his move, right? It's placed on Q, and then our move is not placed on Q. Yes, correct. So Q.push new state. We can be idiots sometimes. I mean, myself. Okay, so we got the output. That is the correct output. Let's see if it will pass. Okay, let's delete this first. Copy, compile. There's some warning here. All right. Moves. This is probably it. We need to cast it to integer because size is not an integer. It was a different type. I forgot the name, but it doesn't make a difference. Okay, compiled correctly. Passed sample test. Submit. Okay, passed. 100%. All right. Well, guys, thank you for watching. If you're watching, this was my first video. There will be many more to come. Thank you very much, and see you next time. Have a great day. Bye bye.